All right, welcome back. This is part 3 in my series of D3, talking about JavaScript and data visualization. My name is Brian Gregg, and I'm going to be teaching you some more foundational topics around creating dynamic data visualizations within the browser using the D3 library. If you haven't gone through and watched my original videos, I would definitely suggest going back and taking a look at some of those core functions and some of the base code that we're using here. It comes, expects that you've learned some of those concepts from those earlier videos. The things that we're going to be talking about today, we're going to start by talking a little bit of formatting, of our SVG images. If you remember from our first video, we talked about creating SVG images in the browser as a way of presenting our data. And since D3 has the ability to modify elements in the DOM, we also have the ability to modify some of their attributes. We've already gone through and modified things like the width and height, as well as the X and Y coordinates of our images on the page, of our elements on the page. And in much the same way, we have the ability to modify the color. So we've added an attribute here of fill. For those of you who have worked with SVG in the past, you'll recognize this as the attribute that defines what color is going to fill in the individual element. And we can play around with this a little bit if we want and change this to different colors, blue or black. And you can see what that looks like. I'm going to keep it as red because I think that red shows up really well on the page, and it just looks nice. A couple of other things that we changed. Well, actually, the only other thing we did was going to reduce the size of this. It was, we're representing quite a bit of data here and don't have a ton of real estate with the screencast format that I'm using here. So I've actually reduced the range here. Originally, this was 50 and 500, and the width of our rectangles, I believe, was 8, and the increments that we were increasing our x coordinates by was 10. So what that was doing was actually, we'll roll that back to the way that looked before. Let's take that to 8, and we'll change these to 50 and 500. And that's what that looked like. So you could see this is actually widening our columns and increasing their length and increasing the x coordinates where each of them starts. And obviously we have the ability to play around with this however we want. And I just think that this is a good representation of the data right here. So with that, we're going to jump right into some modifications to our data here. Let's go on. I'm going to switch this over to main 7, where we've made some modifications that will make our graph here a little bit more interesting. All right. So what have we done here? Let me just comment some of the stuff out here. And we'll take a look at that in a minute. Okay, so the first thing that we've done here is we have taken our function, our render function that we created, and we've added in a second parameter. So originally the only parameter that we were passing in was data. Now we're also passing in a second parameter of metric. And what metric is going to do is it's going to allow us to pass in a value. If you remember when we talked about the JSON object itself, it was representing a population either of males, females, or the total population. So here we're showing the total population. If, for instance, we wanted to show females, we could see that, as well as males. Because really all it's doing is when it's going through this function, it is checking what metric is being passed, and it's taking the value of that metric from our object D and scaling it using the scale function that we've defined up top, and returning that, which is then setting the height of the respective data point that we're visualizing. So this is just a way for us to be able to pass different metrics and be able to represent them in the data visualization here. And that's going to become important shortly when I explain what we're doing here. So what we've actually done is we've added in we've fleshed out the third phase of our render function. So I described earlier that we have four different functions, four different sections of code that are executed in a D3 application. Our initialization, where we bind our data, the enter, where we set up the initial representation of our data, the update, where we're making changes to the data, and then the exit, where we do our cleanup. So what we've done here is we've actually added in a function call to set the attribute of our rectangles on update. So what does that do? Well, if you think about the enter function, what the enter phase is doing is it's taking a look at our rectangles. It's checking to see if this is the first time that the function has been called, and if it is, it's setting all the initial values. Now, when we are coming back and we're rerunning this, so normally if you have a data visualization on your page and you have any sort of interactivity with it, every time that you change the dimensions that you're trying to visualize, or you're changing the metric, what you're going to do is you're going to be changing certain attributes of that graph, but you're not going to be changing all of them. So things like the fill color, and in this case the Y attributes, the width, as well as the X attribute, are not actually changing every time you re-render this graph. The height, however, we are changing because we're passing a different metric, and those metrics are going to have different values. So what we've done is we've added in this update step here, which calls the transition function for a duration, let's do this as 750, for a duration of 750 milliseconds, which is going to change the height attribute of the metric that was passed into the render function. So this really doesn't change anything if we call our render function the way that we've been calling it, but let's say that we add in a set timeout. And if you've never used a set timeout, it's pretty straightforward. It's just takes two parameters. One is a function. The second is a number of milliseconds. And what it's going to do is, after this number of milliseconds from when the set timeout function is called, it is going to execute this function. So let's take a look at what happens here. It starts out with the number of males, and then after a little less than a second, it changes the data representation to the total number of people in the population. Now, let's say we do that again, the number of females after 2 seconds. So remember, I said after this function is called, it's going to wait this number of milliseconds. So let's do that again. It's going to transition to the number of total, then back to the number of males. So what this is doing is it's calling this render function after 1 second, and it's passing a new value for the value of metric, which is then going to call this transition function, and it is going to again call our function passing the value of D, which D represents the entire data set that we're querying against, and it's going to pass back the new value for metric. And that new value is now going to be represented on the page through a transition for a duration of 750 milliseconds. And although this is trivial in this example here because we're just arbitrarily changing the values, if we, say, for instance, had a drop-down menu that let you select a metric using an event listener, we could obviously make a dynamic graph that could be changed based on user input. And we will do that, and probably not in this video, but in an upcoming video. All right, take a quick sip. All right, let's go ahead and point to the next JavaScript file here. All right, so we're getting a little bit more complicated here. We have got some changes here now to our render function. So if you remember in the previous example we were taking a look at, we had our scale was set on the outside of the function. Actually moving that into the render function because I think later on, probably not in this screencast, but maybe in the next one, we're going to want to set some of these values dynamically based off of the data set that's getting passed in. But we've kept this initial scale the same, but I've added in another scale, an X scale. So right now the only thing that we're scaling is our Y coordinates, but we're going to want to scale these X coordinates as well. So I've just kind of arbitrarily set those, but eventually we're going to want to set those dynamically. So let's take a look at what we have below here. We've got two different axes that we're setting up, and this is really what I want to draw your attention to. So what's a graph without axis? An axis is going to tell you what data is being represented in front of you. It's critical to being able to create successful data visualizations, because if you aren't labeling your data, then people aren't going to understand what the data is that you're presenting to them. So being able to assign scales to your data and being able to properly document what it is that you're presenting to them is imperative to successful data visualizations. So what we've done is we've created two axes, an axis and an x-axis. This one that's called axis is actually our y-axis, but that's implied. And what we've taken our scales and we're calling the scale function on our scale and our x scale, and we're passing them back to two D3 functions, which remember D3 is our global object. We're passing them back to two D3 functions. One is axis left and one is axis bottom. And we're assigning those to axis and x-axis. Now, this axis left is just really all this means is it's going to put the axis on the left side of the SVG image, and the axis bottom means that it's going to put it on the bottom of the SVG image. And it actually doesn't have any bearing on the placement at all. So you can call axis bottom and actually display that axis up top. Really all it's doing is it's controlling how the axis is going to be presented, but I'll show you that. And then below here, what we're doing is in our enter function, we're binding a function call to axis and to x-axis within our enter and update phases, and we are setting the attributes on those. We're actually using the transform functions. These are transform attributes. These are CSS attributes that are going to let us adjust where the images or where the axes are going to display on the page. So for the y-axis, we want to actually move that in 60 pixels. That's why we pass 60 here. And we want to start it right in the upper left-hand corner. So that's why we pass the y coordinate of the translate as 0. For the x, we're also going to want to move it in by 60 pixels. And we're actually going to move this one down to 275 pixels, so towards the bottom of the graph. And that's what I meant before when I said that we were going to have to adjust where it was going to be presented. So let's take a look at this. And there we go. So now we have a graphical representation of our data, and you can see that this axis is moved in by 60 pixels, and this x-axis is moved down by 275 pixels. Well, what happens if we didn't do that? Well, let's just say we left this as 60 and 0. It's going to stick this up at the bottom of the, it's going to stick this up at the top. The reason why it's showing up in both places is because of this right here. So let's just make sure we do it both in the enter and update. So if we do that, you can see it's going to stick it up at the top. But that's actually not where we want it. If we did want it up here, like I said, we can use some of the different function calls here for how the axis is being represented. If we were to change this, instead of axis bottom, we called the axis top. Well, it gets cut off. Let's just move that down a little bit. Let's just say 10. Actually, let's do it on this one, 10. And this one is 10. Yeah, so you can see it's kind of, it's a little offset, but you get the idea. It's actually presenting the graph so that it's pointing upwards. There we go. So see how the axis top is going to face the data points upwards, whereas if we just jump back here, change that back to bottom, and add those back in, you can see the data points now are facing downwards. So this is nice. We can actually do quite a bit with this once we start binding our data. But one thing I want to point out, and this is something we're going to have to fix, is you can see that our data goes here from 0 to 100, but our graph starts somewhere between 70 and 80. And the reason why is because I've kind of set some arbitrary values to display where our x coordinates are. And we're actually not binding our x coordinates to the data. So this is something that we're going to have to fix. And I'm going to show you how to do that in this next module. Get that out of here. I don't want that. Okay. So let's go back to our index. And we're going to move this up to main 9. So what we want to do here is we actually, well, we're going to do a couple of things here. We're going to make, the most important thing that I want to point out is that we want to make x a function of the data. So if you remember when we were talking about our height, what we did was we took our scale and we passed the value for the particular data point for that metric back to our scale function, and that's what we set our height as. So if, for instance, we had 500,000, that 500,000, hold on for a second here, because that's going to bite us later. Let's just make sure that this looks okay. Okay. What's going to happen here is if say we had a value of 500,000, that 500,000 would map in our range to 25. This function here would return that 25, and that's what the number of pixels that the height would be for our data point. The same thing here we want to do with age. Let me just move this down. What we want to do is we want to take our age, and we're actually going to pass that age back to our x scale. And what this is going to do is it's going to say, all right, if the age is 1, it is going to pass it back to our scale over here. And our scale is going to say, okay, 1 that, or actually 0, let's say 0. 0, that's going to get from our range a value of 0. If it was passing 100, it would pass it into our domain of 100, and it would return 540. And 540 is what's going to be returned here. We add 60 to that. That's just for this offset over here, because if we didn't have that, what would happen is our graph would overlap our axis. And then for every data point, it is now going to increase that scale. And now you could see that 100 actually lines up with the maximum value here, and 0 lines up with the minimum value. So we now have both our scales and our x and y coordinates are bound to our data. So if we only had data going up to 80, well, let's actually show what that would look like. So let's take a look at our render function here. And what I'm going to do is I'm going to be using a filter function here. Okay, and filter is basically a function that you can call as part of the array prototype. And we are going to pass a function. All right, and this function is going to say return a.age is less than 50. All right, let's see if that works here. Okay, and this is now, what this has done is this is, if you've never used the array filter functions before, what this is really, all this is doing is taking your data set and it's passing it to a function. It's passing a, which is a reference to the object, and is returning all of those objects where the age is less than 50. Let's see if we did it greater than 50. And there we go. It's now representing that data on the graph on the for all of the values where it's greater than 50. Filter is a great function that you should familiarize yourself with if you're going to be doing a lot of manipulation of data in JavaScript, because it kind of gives you the ability to adjust which data is being represented without actually editing the data, without actually modifying the data. So you want to make sure that when you're working with data sets that you're using functions that are immutable, because you don't want to mutate your data. You don't want to make changes to your data in case you need to go back and pull out the original values. So definitely a good thing to work with there. But as you can see now, we can show data. In fact, if we actually, let's play around with this a little bit. Let's say return a where a.total is greater than 4 million. Okay, so there you go. Now this is showing only those data points where the total is greater than 4 million. Pretty cool. So there's some stuff you can do there. The last thing that I want to talk about is, you see this data. One of the things that's really irked me about this is the fact that we're starting from the top and working our way downwards, and that's because of the way that the Y-scale is handled within a web page. It always starts from the upper left-hand corner, whereas when we're representing data, we usually want to start from the lower left-hand corner and work our way upwards. We can actually do that, but it's going to take a little bit of manipulation. So here we have our main10.js, where we actually are going to transpose the axis. So the way that we're going to do this is we're going to adjust our scale, not our x scale, because our x scale stays the same because we're still going from left to right. But instead of going from top to bottom, we're going to want to go from bottom to top. So what we're going to do is we're going to leave our domain the same, So we're still going to go from 500,000 to 5 million, but instead we're going to swap our range. So we're going to start at 250 and then go down to 25. And this will make sense in a moment. What we're going to do when we actually render our data is on the enter phase, when we set our attribute for y, instead of setting it to a static value, we're actually going to set it to a value of metric. And now you remember, before what we were doing when we were representing the data was we would start at y, a static value, and then we would go up to metric, which was represented by a direct correlation of the range to the domain, starting from smallest to largest. Now instead what we're going to do is we're going to start from largest to smallest. So rather than representing our data going from the top of the screen to the value, we're going to go only the distance that would normally be covered by this empty space right here by swapping the ranges. So we'll go down, let's take the example of 500,000. So 500,000 would normally be mapped to 25 in our previous example, which means we would start here and then go down 25 pixels. Now instead what we're going to do is we're going to 500,000 is going to map to 250, so it's going to go down 250 pixels, and then it's going to that's where the y value is going to start. Then we're going to take the scale of 0, so the scale of 0 is actually the maximum value of our graph, and subtract that 25. So if the scale of our graph is 250 and we subtract 25, it is going to give us a height of 25 pixels. So what we're doing is we're kind of inverting the graph. Instead of starting at a static point and then increasing that by the height of the rectangle based on the data point, we're going to be using the data point to define where we start, and then subtracting that value from the total value of the graph and deciding where it's going to end. So let's actually take a look. Oh, and obviously we're going to want our y attribute to be set dynamically as well, since that is going to it's going to have to be set both in our enter phase and in our update phase, just to make sure that it happens when if for instance we have to make a change to the graph. We want the y value to be updated every time we re-render the graph. So let's take a look at what that looks like, and that is exactly what we wanted to see. So here we have a value of 400,000, or I'm sorry, 4 million. And normally what that would do is it would start up here in the upper left-hand corner and then be represented by a height of 4 million. Instead, what we're doing is we're taking that value of 4 million and we're inverting the range so that we're starting here, and then we're taking the total value and subtracting that, so that equals the height. That's why we're able to now represent the graph in a way that looks more representative of the data. So definitely something that may take a little while to kind of wrap your head around how we're doing that, but it definitely is critical to being able to manipulate your data within the space here, because again, the way that the browser is going to render your data is not necessarily in line with the way that we've been taught to look at data, which is always starting from a value that's in the lower left-hand corner of the page, as opposed to the computer, which treats it from the upper left, the upper left corner of the page. So hopefully this was helpful. It's definitely something that I've enjoyed doing, and if this is something you'd like to see more of, subscribe, like, share, and comment to let me know that this is something that you want to see more of. Definitely got some content planned for some future screencasts, which I'm going to be working on, and hopefully be getting those out soon. All right, thanks again. Have a great night.